Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is minimum difference in sums after removal of elements. Now the problem category is of hard level, and I would say the problem is a bit hard. From the understanding perspective, understanding the problem and the solution approach, it is a bit easy. But coding the solution of this problem, even though you know the solution approach, even though you know the intuition, coding the solution is a bit hard. So I would say yes, it is a bit hard problem, but that's fine. Let us start solving the problem and let us see how hard or how easy it is. So the input given in the problem is an integer array. Let us call it as nums. And the question says that the length of this array nums will always be the multiple of 3. So let us say it is 3 multiplied by n, right? So the length of the array can be 3, 6, 9, 12, something like this. It will be a multiple of 3. The output we need to give is the minimum difference possible between the sum of two parts of the array after removal of n elements. Now this statement is a bit big, but let me explain you that. What we need to do is, we are given an array nums, and the length of nums is 3 multiplied by n. That is, it will be a multiple of 3, right? So if it is a multiple of 3, then the array will have total 3 multiplied by n elements, right? So I can say the array has n elements, n elements, n elements. The array has a total of 3 n elements, right? If I divide the array into 3 parts, the first part is having n elements, the middle part has n elements, and the last part has n elements. The question says that find the minimum difference which is possible between the sum of two parts of the array after removal of n elements. So let us say if I remove these n elements from the array, now I have total 2 multiplied by n elements in my array. The first part will have n elements, the second part will have n elements. I need to find the difference, the minimum difference which is possible between the sum of the first n elements in my array and the second n elements in my array. So basically, out of the 3 multiplied by n elements in my array, I have to remove n elements. I will have total 2 into n elements in my array. Now I need to divide my array into two parts. N element will be the first, n element will be the second part. We just need to take the sum of the first and second part and find the difference between both the sum. Our goal is to minimize this difference. Find the minimum difference which is possible between the sum of the two parts of the array after removal of n elements. So the question is all about how can we remove n elements from the array, and we can remove any n elements from the array, right? But our strategy has to be that remove the n elements in such a way that out of the remaining two n elements, the sum of the first part minus the sum of the second part, this particular value, this particular difference has to be minimum possible. Now let us try to understand the problem with one example. In the example, the given array nums is 7, 9, 5, 8, 1, 3. So there are total of 6 elements, and as we know from the question that the number of elements in our array will always be a multiple of 3, right? So since the value of length in our current array is 6, and we know that it is a multiple of 3, so we can say the value of n, that is 3 multiplied by n, is equal to 6. So the value of n is going to be equal to 2, right? So we can actually break our array into 3 parts of 2 elements. So I can say the first 2 elements, the next 2 elements, and the next 2 elements. These are my 3 parts. Now the question says that remove any 2 elements from this array such that the sum of the first part minus the sum of the second part, this value is minimum, right? Now let us say, just for an example, if we remove these 2 elements, 7 and 9. So the first 2 elements in our array, or the first n elements in our array, is 5 plus 8, 13. The last 2 elements in our array, their sum is 4. Their difference is 9. Now this is one of the possible case. This is one of the possible thing we can do. Remove the first 2 elements. After removing the first 2 elements, the difference is 9. We can do it better. What we can do is, we can say, let us remove 9 from here and 1 from here, right? And now you will see that our array is 7, 5, 8, 3. The first n elements in our array is 7 plus 5, which is 12. The last n elements are 8 plus 3, which is 11. 12 minus 11 will be equal to 1, right? And that is the output we have in this particular input. So when we removed 7 and 9, the difference was 9. When we removed 9 and 1, the difference was 1. So this is the best answer we have. The output is going to be 1. That's the minimum difference. Now, the first observation which you have to make is, when you remove n elements from your array, you will have total 2 n elements, right? 2 into n number of elements. Now the thing is, the first n elements out of these 2 n elements will go to the first part. The last n elements will go to the last part, or the second part. Our goal is that the sum of the first part minus the sum of the second part, this value has to be minimum, right? If you want to minimize this value, let us say I want to say x minus y. If I want to minimize this value, then x should be as low as possible, y should be as high as possible. For example, if I say 5 minus 11, it is minus 6, right? This is low, this is high. But if I increase the value of this 5, let us say I make it as 15, 15 minus 11, this will be 4. So it is a simple maths that I have to make sure that the first n elements are as low as possible. The last n elements in my array, after removing total n elements from my array, should have values as high as possible, so that the sum of the first part is as low as possible, the sum of the second part is as high as possible. And then when we take the difference, we are going to have our best answer. Now the second most important observation which you have to make in this particular problem is, you are given a total of 3 multiplied by n elements, right? You have to remove n elements out of this, and you will be left with 2 multiplied by n elements, right? Now you have to take the first n elements at the first part, the last n element at the last part or the second part, take the sum of the first minus take the sum of the second. Now here we can observe that these n elements will always be the part of the first 2 into n elements of my original array. And this is a very important observation. The first n elements in the 2 multiplied by n elements of my array, after removing n elements from 3 multiplied by n elements from the original array, you have 2 multiplied by n elements, right? Out of these 2 multiplied by n elements, the first n elements, which is going to be the part of your first array, these n elements will always be the part of the first 2 multiplied by n elements of my original array. And let me try to prove that to you. And before that, you will also need to observe that the last part or the second part of your array, the last n elements, this will always be the part of the last 2 into n elements of your original array. Now let me try to explain you the fact with this particular example. You have a total of 6 elements, right? If you have 6 elements, then you can say the value of n is 2, right? Now you have to remove total 2 elements from your array and you will be left with 4 elements, right? For example, in this case, when you removed 9 and 1, you are left with 7, 5, 8 and 3, right? Total 1, 2, 3, 4 elements, right? Now, out of these 4 elements, the first 2 elements are the part of your first array, last 2 elements are the part of your second array. The first 2 elements are 7 and 5, the last 2 elements are 8 and 3, right? Now here what I am saying is, the first 2 elements which you are going to get for your first array will be the part of the first 4 elements of your original array, and the last 2 elements, that is 8 and 3, this will always be the part of the last 4 elements in your original array. And that is because, let us say we are creating the first 2 elements of our array, right? 7 and 5 is what we got. Let us say we don't know about 7 and 5. So what I am trying to claim is the first 4 elements will contain the first 2 elements which I am trying to get for my first array. If I remove any 2 elements from this, because I have to remove a total of 2 elements, right? If I remove any 2 elements from my whole array, let us say I remove the last 2 elements, right? If I remove the last 2 elements, then also the first 2 elements in my array 7 and 9 is the part of the first 4 elements, right? Let us say I remove the first 2 elements, then also the first 2 elements in my array, that is 5 and 8, will be the part of the first 4 elements of my original array. So you can remove any random element. Let us say we remove 9 and 1. Still we have this 7 and 5. This will be the part of my first 4 elements. We have 7 and we have 5. Because we are removing a total of n elements, right? If we are removing a total of n elements out of 3 n elements, we are left with 2 n elements. The first n element will always be the part of the first 2 n elements in my original array, and the last n elements will always be the part of the last 2 n elements of my original array. And this is something which you will have to understand, right? Now using the first fact that I have to make sure that my first array should have the least sum and the second array should have the most sum, and the second fact is my first array will be coming from the first 4 elements, the first 4 element, right? And the second array will be coming from the last 4 elements, right? This 4 is coming from 2 multiplied by n, right? For this case, the value of n is 2. So what I will try to do is, I will try to find out the least sum which I will get for n number of elements for my array. Because I know that the first 4 elements are going to give me the elements for my first array, right? So I will try to find out n such elements in my first 2 n elements such that the sum of n elements is minimum. So basically if you will see in this array 7 plus 5, that is 12, because we have to select total n elements, that is 2 elements. So we can select 7 and 5 and the sum is going to be 12, right? We get the sum of 12 from the first 4 elements by selecting n smallest elements 7 and 5. We get the sum as 12, right? Also talking about the last 4 elements, I need to maximize the sum, right? So what I will do is I will say, okay, 8 plus 5, that is 13. That is the maximum sum we have. But here is the problem. 5 I am claiming to be the part of the first array, right? 7 and 5, right? If I am trying to create the first array and it has 7 and 5, then 5 cannot be the part of my second array, right? So I have to say, okay, let me ignore 5. Now my maximum sum is 8 plus 3, which is 11, right? If 11 is my sum from my second array, the maximum, and 12 is the sum from my first array, the minimum, their difference is 1. That's the output we need, right? How can we solve it? Try to think about this. See, the thing is, let us first process the first 4 elements to get the least sum of n elements. Now the thing is, you might say, okay, let me select the 2 minimum elements, 7 and 5, and get the sum, which is fine. But there is a problem with this. Even though I can just select 2 minimum or n minimum elements from my array, and 7 plus 5 will be 12, I cannot say that at every point my least sum is going to be 12. And the reason is, let us say, if I'm saying that the least sum I'm getting here is 12, okay? At this point, I might have selected elements from this part of the array, this middle part. And you know that for my second array, I have to select elements from these 4 elements, and it is including these 2 elements, right? That's the middle part. So there is a chance of collapse, there is a chance of overlapping. So we cannot just randomly say that for this particular array, my minimum sum is 12. Because I may have chosen some element, and later on, when I have to select elements from for my second array, I will have a conflict. So what I will do is, I will try to find out the least sum, least sum of n elements at each point of my first 4 elements. What I will do is, I will say, okay, for the first element, the sum is going to be 7. Although for the first element, I don't care. That is because I need at least n elements, right? I need at least n first array elements. So n is 2. So if I get just one element, whose sum is 7, So I will not be worrying about this particular value. Now I have 9. I have seen total 2 elements. I can say, okay, as of now I have seen 9, 7 and I have seen 9. These are my minimum 2 elements as of now. Their sum is 16. So at this point, the sum is 16. Now how is this going to help us is, because if I know at this point my minimum sum is 16, so I am claiming that I am selecting elements from this array for my first array. Now for the second array, I have all these 4 elements free, and I can use all these 4 elements to select my best 2 elements for the second array, right? So that is why we are doing it point by point at each index. So I can say at the first index, the sum is 7. At the second index, the sum is going to be 16 because now we have 2 elements, 7 and 9. We have to find the sum of the minimum 2 elements. At this point, the minimum 2 elements are 7 and 9. Sum is going to be 7 plus 9, which is 16. At this point, you will have to understand the moment we see this particular element, I will say my current sum is 16. But since I have a 5 now, I can remove this bigger value and replace this with a smaller value. I can reduce 9 from this and add 5. That is because I just need the sum of 2 elements. The moment I know that I have a 5, I am sure that the sum of two smallest element is going to be 7 and 5 because 9 is more than the upcoming value. I have a bigger value in my array, which is 9. I will get rid of it. I will replace it with a smaller value. I will have 7, 5 now for my first array. I get two elements, 7 and 9. I say that my maximum sum is 16. Now I get one more element, 5. I only need to consider n elements, that is 2 elements. I will remove a bigger value to replace it with a smaller value. So now my array is 7 plus 5, 12. So at this point, after I have seen 7, 9 and 5, my minimum sum is going to be 12. 7 and 5. Now I have to consider this as well because my first array can have elements from the first 4 elements, right? So I will consider this as well. Now my array is 7, 9 and 5. We are considering 7 and 9 as our lowest 2 elements for the sum, right? For keeping it here, for the value we are keeping here. Now we are getting a new value as 8, right? We don't have a 9 because we removed 9. As of now, our highest value in the array is 7. The new value which we are getting is 8. This 8 is more than our highest value, so we don't need this 8. Because we need to minimize the sum at each point in my array and we need to consider a total of n elements. So at this point we just have 7. At this point we have 7 and 9, 16. At this point we have 7 and 5, 12. At this point the minimum sum is going to be 12, that is 7 plus 5. Because at this point we have seen a total of 4 elements. Now we are going to do the same for the last 4 elements, but this time our aim will be to maximize the value, right? And this will come from the last n elements. Now before this you will have to try to understand one very important thing. When we are saying that the sum at this point is 7, we don't need to consider this because we need to consider at least n elements, right? So let's start from here, right? At this point we just have one element. So let us start from here and we are saying that at this point we have the minimum sum as 16, right? If we have a minimum sum of 16 at this point, we are considering 9 and 7 as the first n element of our array. And now we have all this array to consider our last 2 elements or last n elements, right? So from this particular array, I have to find the best n elements which has the highest sum so that I can get the minimum difference, right? At this point, I have the minimum sum as 16. In this particular array, I will have the maximum sum as 13, basically 8 plus 5. I will come on this, that how we can compute, but 8 plus 5, right? So basically what you have to understand here is at this point, I can consider all these 4 elements for my second array. But when I'm considering this particular point at which my minimum sum is 12, that is 7 plus 5, at this particular point, what I want is, I want what's the maximum sum you have from these 3 elements. If I'm selecting the last n elements for my array, I will select a total of 2 elements. The maximum sum is going to be 8 plus 3, 11. And from this particular array, the minimum sum is going to be 12, right? 7 plus 5. So their difference is going to be 1. So basically what I want to say is, if you are at this point, you have to consider these 3 elements. But if I am at this point, I am saying that, okay, if I am choosing all the first 4 elements, and out of this, I am selecting the minimum 2 elements to get the sum as 12. Now the second array has just 2 options. It can select its best 2 elements from this array. It cannot use these 2 elements, right? So what I have to do is, I have to move from right to left. And then I will be computing the sum of the best n elements or sum of the highest n elements so that I can find the best n elements at each point in my for my second array, right? Basically at this point, if I just know about 3, I will be having 3 here. If I just know about 1, I will be having 4 here because 3 plus 1 is 4. Now I have 2 elements, 1 and 3. The best 2 elements are 1 and 3. The sum is going to be 4. Now once I see 8 as well, I will have 8 plus 3. These are my 2 best elements. So the sum at this point is 11. And when I have 5 as well, so these 2 are my best elements. So I will say at this point, my best sum is 13. So you will have to find the cumulative sum from left to right for the first array and cumulative sum from the right to left for the second array. And why right to left for the second array? And that is because if you will notice here, this 13 is coming after we are considering 5, right? If we are considering 5 in the second array, my first array has just 2 options, the 7 and 9, right? The sum is 16. What I'm basically saying is, at this point, my best sum, my lowest sum is 16 for the second array. At this point, my best sum or my highest sum is 13, right? So I have to take the difference of 16 and 13. The reason is, this is my first array. This has my second array, right? Of course, I'm selecting the sum as 13. It means I'm selecting the best 2 elements, right? So basically, whatever is my dividing point between both the arrays, I have to select the lowest 2 elements from the first, highest 2 from the second. And now we have to take the difference between 16 and 13, 12 and 11, 12 and 4. I will tell you the reason for this. 16 and 13 difference is 3, 12 and 11 difference is 1, 12 and 4 difference is 8, the minimum is 1, that is your answer. And why are we doing this? The reason is, at each point, if you will notice, at each of our point at which we have total number of n elements in both the array is this particular point, this particular point, this point, and this point. At this point, we have total 2 elements sum here, right? At this point, we have total 2 elements sum. At this point, we have total 2 elements sum, right? For the second array, at this point, we have total 2 elements sum. At this point, we have a total of 2 elements sum. At this point, we have a total of 2 elements sum. For the first array, we are considering the lowest 2 elements. For the second array, we are considering the highest 2 elements, right? Let us say you are at this point. So I am saying that I am considering these 3 elements for my first array, and the best sum is 12, right? The lowest sum is 12. So I will be left with these 3 elements. Their best sum is 11, right? Which is this one. That is why 12 minus 11. When I am saying that this will be my search space for first array, I am saying, okay, at this point, my best sum is, my lowest sum is 12. So at this point, I am also saying that my second array just has these 2 elements as the options, and their sum, their best sum is going to be 4. That is why 12 minus 4. That is why 16 minus 3, right? So we just basically need to find for the first 2 n elements, what's the lowest sum possible considering total n elements at each point, and for the last 4 elements, what's the highest sum possible considering each point of total n element. Take the difference, and that is going to be your output. And I know it might be a little bit complex to understand, and guys, trust me, understanding it is still easy. Coding it is a little bit more complex. So now let me go back to the code editor. Let me try to show you the solution for this particular problem. And again, it is going to be complex, but still let us try to understand it. First of all, we are trying to find out the value of n, right? Then we are trying to find out the total sum of first n elements. And let me try to explain you this complete code using this particular example, the example number 2. You have a total of 6 elements. The value of n is going to be 2, right? Then the total value, the value of total is going to be 7 plus 9, basically the sum of first 2 elements, right? So this will be 16. At this point, we have the total as 16. Now we are saying that the value of max heap, we are trying to create a heap here, and the reason being, at each point when we see 5, then we see 8, we are trying to consider only the best n elements. So we will try to maintain a max heap in which we are going to remove the max element and replace it with the upcoming lower value. So for example, we have 7 and 9. Let us say we have 7 and 9 in the heap. The maximum is 9. Now we see an element 5. We will try to remove the maximum, which is 9, and replace it with 5. The reason being, we only need to consider the best smallest 2 elements for the first array, right? So as of now, we are trying to do it for the first array. So for the first array, we are considering the first 4 numbers. We will try to do it using the max heap. So in Python, to implement a max heap, we have to insert our numbers as negative, because by default, the heap works as a min heap. So we are inserting our first n elements as negative. That is, our max heap will have elements like -7 and -9, and we are going to heapify this. Now our data is heapified. It will perform as a heap. Now we try to pre-compute the values, basically the values which I have shown you in the drawing pad, that the values were 7, then 16, then 12, and 12, right? So as of now, we know about the value 16. What we are going to do is we are going to create a pre-table. It will have total 4 elements. Initially, it is going to be 0 and 0, and we are saying that at index number 1, that is my second element, is going to be equal to total, right? Which is the case, right? The first element will be 7. We don't care about the first. We care about the second. It will be 7 plus 9, which is 16. And we have already calculated its value, right? Now, we run a loop for these 2 elements. That is, we will see the 5 first and then 8. And we will try to update our pre-table value. The table value is as of now 0, 16, 0, 0. We don't care about the first value. We just care about 16. Then these 2 values, right? These 2 values will now become 12 and 12 after this particular loop. Let me explain you how. What will happen? We are going to run a loop from the range of n to 2n. That is, the indexes are going to be 2 and 3. Then we are going to update the value of total. Total will become, it was 16. Now 16 plus 5 will be 21. We have the total is 21. Now what we are going to do is we are going to update our heap, update our max heap. We are going to say, in our max heap, let me push one more element. Let me push this 5 as negative. Once I push this 5 in my max heap, I have 3 elements, 7, 9, and 5. Now I will pop out the maximum value from this. So I will pop out 9. So now my heap will have 7 and 5 after the line number 14. The heap will have 7 and 5. And then the total will be equal to total minus the negative of this 9. The negative of this minus 9, because we inserted this as -9. So our total was 21. Now it will be 21 minus 9 will be 12. So we are updating our pre of I as 12. Then again it will run for 8. What will happen? It will be total. Total will be 12 plus 8 will be 20. And then we have this again. We will push our 8 into the heap. Our heap has -7, -5, and -8, right? Now when we will try to pop out a value, basically 8 will be popped out as negative, and we will say our sum was 20, will be 20 minus 8 will be 12 again. So our array will now become 0, 16, 12, 12, and that is what we wanted. Again, the same thing will happen using a min heap. We will try to build the second array, and for the second array, we are going to use a min heap to calculate the same thing. But why min heap? The reason is, now we are trying to find out the 2 best values, the 2 highest valued values at each point, and we are running a loop in the reverse order. Why we are running the loop in the reverse order? Because we are filling the values from right to left. So it is a bit hard to explain the complete code. It will be better if you just try to understand the code. So this is the part where we are updating the second array, and then finally we are just comparing our pre-array and suffix array, because the suffix array is basically we created for the second array. So we are comparing the values in the pre-array and the suffix array. In the pre-array, if the index is I, we are using the I plus 1 in the suffix array, and that is something which I have already shown you in the drawing pad. And you have to take the difference, and whatever is the minimum difference, we just need to return that as an answer. We are storing it in the variable answer. So again, guys, this will be a little bit complex to understand. So let me show you the complete code. Let me scroll a bit. You can just pause the video and see the code. Try to focus more on the solution approach. And then I would also suggest you to try to focus more on the code as well, because the code is a little bit complex. The understanding is a little bit easy, but coding it is very complex, I would say. Especially if you have less idea about the heap data structure, then it will be really difficult to understand. But if you know about the heap data structure, then I would say just give some time to the problem, just give some time to the solution, and you will understand everything. So that's it for this video, guys. I hope this video helps you to understand the problem, and at least you got to know something from this video about this problem and the solution approach. And if you did, then make sure that you hit that like button. But if you have any questions, any concerns, which I think will be there because the question is a bit tricky and the solution as well, so make sure that you put it in the comment box. I will try to answer that. And if you are not subscribed to my channel, we are very close to 1000 subscribers, then make sure that you hit that subscribe button as well. And I want to see you guys in the next video. I will see you guys in the next video. Thank you for watching this video, guys.